Hello, this is Gaurav Barmula and this is my video for DSP lab exam. So this here is our problem statement. So we are given a PPG signal and we have to find the pulse rate using that PPG signal. But this PPG signal also have some noises. So it has a baseline drift of less from 0 to 0.5 hertz, and it also has some high frequency voice noises greater than instrumentation noise greater than 20 hertz. So we have to filter out these noises and then we'll have to perform some signal processing to find the pulse rate. Also, it is given that the suitable pulse rate, the range for pulse rate is 330 to 300 bpm, which translate to 0.5 to 5 hertz, which is our desired range in which we'll perform the signal processing. So this is my submission. So first of all, some theory. So PPG sensor works. They basically use the principle that different tissues have different optical properties. So PPG sensor illuminates our screen with some green light, and it absorbs the different absorption of light by different tissues, and to make a signal. So also there was a question about its significance with reference to COVID-19. So PPG sensors are very readily available. They are inexpensive. So it can provide a very scalable solution to, like, we are going through a pandemic. So it can give a very scalable solution because we can mass produce PPG signal very inexpensively, and it is like very easy to apply on large scale. So basically we can use two approaches to do this. We can use autocorrelation function and we can use DFT. In both ways we have to find the peak frequency. In autocorrelation we find the zero crossing point, and then we find the peak frequency, and also in DFT we also find the peak frequency and then find the pulse rate using that peak frequency. So this here is our block diagram. Okay, so this is the block diagram of I'm using autocorrelation function approach. So we'll take the PPG signal and first pass it through a moving average filter. So what that will do is it will smooth out the signal, and also additionally it will also filter out these like low frequency noises, so we do not have to use a high pass filter. So after passing through moving average filter, we'll get a smooth out signal, and then we'll pass it through a low pass filter to filter out these high frequency noises greater than 20 hertz. So what that will do is it will give us a noise free PPG signal in which we can perform our digital processing. So we'll find the autocorrelation function of that signal, and using that autocorrelation function we'll find the zero crossing of that ACF. Now we'll find the peak frequency after the zero crossing point of the signal, and using that frequency we can find the period and hence the pulse rate. So this here is the expressions for our filter. So moving average filter is very basic. We just find the average over particular length. Whatever the length of moving average filter is, we'll find the average of all individual values over that length. So what it does, it smooths out the signal and also filter out like low frequency voices. LPF, we are using LPF to cut off frequencies higher than 20 hertz. So it is also given that this is 100 hertz. So basically we'll find the phase for this LPF. So that is 20 upon 100 into 2 pi. That gives us this 2 upon 2 pi by 5. And also using this we can find R. R is basically 1 minus this. So okay, this is not actually very clear, but this is the expression for LPF using this value of R and phase. And also this is the basic expression for autocorrelation function, that is this sum divided by so this is basically energy. So this is the expression for autocorrelation function. Okay, so okay, I wrote the code in a lot of hurry, so I skipped a lot of things. So basically I have not done the filters in it. So I've started with autocorrelation function. So basically first we'll do the like we will also have a moving average and low pass filter before this particular thing, but like due to time constraint I couldn't write that. So this is our loop for autocorrelation function, which basically this is just implementing this particular sum on this, and after we'll achieve this autocorrelation function, we'll use that ACF to will find the zero crossing point of that ACF. Okay, so how we'll find the zero crossing point is we'll doing yi into yi. So what this will do, it will basically whenever the sign will change, it will store that index wherever the first time the sign changes of the ACF. So this will give us the index of the zero crossing point, and using that zero crossing point we'll find the peak. So for peak, okay, I have also not written, there should be another thing, like if this is greater than max will also equal, will also have to update the value of max. So basically max equal to yi is absent here. I forgot to write that due to time constraint. So we'll just go through the signal after the zero crossing point and find the maximum, the index corresponding to the maximum value. So another line will be here, max equal to yi inside this if loop, if condition. So if when we'll get this peak frequency, then period will be equal to peak upon fs, simply peak upon fs. Okay, video is little longer than 6 minutes, but I think you can manage. So on the pitch frequency, okay, when period will is peak upon fs and pitch frequency is 1 upon period. Also one thing that I did not write is pulse rate. So pulse rate is basically 60 multiplied by this pitch frequency. So another statement will be here for pulse rate, and that will give us the pulse rate using the PPG signal. Thank you.